Hey, Build Show. Steve Baczek Architect here. We are out on site at our multi-gen on a budget project. And this week we are going to talk about floor framing. We got a bunch of the floor frame in down here. We got walls going up above us. Framers are working hot and heavy. Let's get after it.
Multi-generational home on a budget. A Build original series brought to you by Zip System Building Enclosures, Fantech, New Wool, Bosch Home Comfort.
All right, so we're down here. We're at the lower level. Remember, I think I might have mentioned, if I haven't, I don't like to call this the basement, right? This is a multi-gen house. What we mean by that is downstairs here is in what we would call an ADU, accessory dwelling unit. So one of the client's sets of parents are actually going to live down here. It's a 900 square foot, one bedroom apartment that just has, some beautiful views out here. And then the two successive floors above us, the first floor and second floor, are the primary residence for the actual client. So down here at the lower level, you can see we have concrete wall on one side, basically holding back the ground. Over on this side, we have the walkout. Now, all of this stuff we covered over when we were talking about the foundation and how it steps out for the walkout. And I know we're concentrating on the floor framing here, but if you're just joining us and this is the first episode you're watching, I'm just giving you that quick overview. So they say walk with a big stick. I couldn't find a big stick today, so I stole one of the surveyor's stakes. Hopefully he doesn't mind. Honestly, we're beyond him caring at this point because I got it in hand. I needed a pointer, so let's get after it. Open web floor trusses, right? When it comes to floor framing, you basically have maybe 3 or 4 different choices. You have solid sticks, 2x10s, 2x12s. The beauty of those are that they're a standard commodity. You can get them at any lumber yard. One of the problems are that even a 2x12, once you start pushing, say 17, 18 feet, you're starting to come to the limitation of what they can go to. And we're at 20 feet here. So we would have to introduce an intermediate support here rather than what we have here, which I would call a simple beam, or what the structural industry would call a simple beam. Simple beam is basically a floor joist that's supported on 2 points. And the middle wants to bend, right? And the floor joist there is reacting to that load and not wanting to bend or deflect, which is the term used in the structural world. So we have to worry about the deflection, but these are simply supported on the wall there, the wood frame wall, and the foundation mud sill on this side. In addition to the 2x10, 2x12, we have engineered floor joists, which could very easily handle the 20-foot span with probably a 14-inch depth, which is what these are. But the problem with engineered floor joists is you still have a solid web member. And you can see there's already some ductwork being laid out here in the open web trusses. And we're going to talk about why that may seem a little premature to you. But after that, we have open web trusses. And you might have seen some of my other videos where we've used a trimmable open web truss. In this case here, these are manufactured trusses, right? So we have the bottom cord, the top cord, we have our web members, which are the ones that make up the inside, and then we have our metal plates that basically hold it all together. Now, one of the interesting things that I learned back in school, back in the day, was if you looked at how forces move through a solid 2x10 or 2x12, they basically ping pong between the top of the joist and the bottom of the joist. So when you look at a truss and you say, well, how can we cut out all of this stuff and make these very light members? all we're really doing is the truss is a direct diagram of how the forces move through even a solid sawn joist. So in a solid 2x12, basically all of this triangular space really isn't doing a lot in that solid sawn joist. It's working like these trusses are, but for the sake of ease of cutting and milling it up, we keep them as solid sticks rather than go in and try and cut out the parts of the floor joist that aren't being used. Now, one of the beauties of the manufactured floor truss is you can see there's a lot of openings here, right? We can run plumbing through here, we can run electrical through there, we can run our HVAC duct through there. The one caution though is you have these metal plates. The metal plates are usually exposed on top, so you just want to make sure if you're pulling electrical wire or running piping through that you're not scraping those metal plates and damaging any of the electrical or the plumbing. You want to exercise some care in that installation. But you can see, again, this is wide open. It allows for that stuff to be run through. And you can see here we have a couple of our ducts already in place there. We also have a larger oval right here, and we have a couple more ducts there. Now, also notice directly above me, we have a steel frame here. And that steel I-beam is not carrying a vertical load, meaning it's not working in the simple beam format that the floor joists are. That's actually connected to a steel column and a very, very short column here. And what that is doing is battling the lateral load. So when the wind blows on the wall, this is what resists that lateral load of wind, or if we had an earthquake here, that also helps with the lateral load. And you can see that beam is structurally tied, bolted to a plate that then is nailed to the floor joist. So basically you have this beam doing the work of repelling any lateral load coming into it, but it's getting the assistance in distributing that resistive load via the shear diaphragm of the floor, because it's literally connected to the floor. So rather than just have this I-beam, now we have this very large diaphragm that's directly connected to this steel beam. So when the wind blows on the side of the house, that whole floor system in concert with that beam is resisting that lateral load. Ductwork. Why is that already installed? It's a little bit out of sequence, but understand two things are at play here. One, because you have the open web floor trusses, we can't just simply snake in a 16 or 18 foot piece of ductwork. So we needed to be able to put that ductwork in before we close up the end of the wall. So you can see here on this side, the mechanical guys, they fabricated the ductwork and they simply ran it through the band joist and slid it in here, and it's appropriately sized, it's appropriately located. Both sides or ends of the ductwork have been properly sealed, so we're not going to get birds building bird nests or something inside that ductwork there. But now it's in place, and it's just going to simply sit there and wait till we get the house framed, and then the mechanical guys will come back, put it in place, secure it, attach to it, and do their work. Because we have that moment frame here, we couldn't put all the ductwork in one side because we have that roadblock there. So we had to run the ductwork on this side of the beam through the truss, and then we come over onto this side, and you can see we have a number of pieces of ductwork, and we ran all of that basically up to the beam, and then we'll make a connection. The mechanical room is literally like right here under the beam, so we'll be able to go up and connect to both of those. Think of it as two kind of giant L's that will go through. But this is kind of the planning that you have to go through with the truss manufacturer, myself as the architect, and the builder. And in this case here, we used Energy Vanguard that did all of our duct and manual J calculations, equipment sizing, etc. And they did the duct layout. So we all had to work in concert with each other to ensure that we're getting the proper stuff in, it fits, and likewise, we're putting our HVAC system in a position for success. So let's talk a little bit more about the framing. Notice all of our framing members, like I said, 14-inch floor trusses, 16 inches on center, not a whole lot of magic there. One of the things, because this house isn't very large and is a pretty simple frame, instead of using LVLs, our truss manufacturer just made a couple girder trusses here. And the girder trusses basically, they're called girder trusses because they fly from the wall to the framed wall over there. But notice they're also picking up these two trusses that are working as girder trusses and bringing that load in. So when you're talking about the floor load, say for the living room above here, notice the load path is such that each one of these joists brings the load in. It brings the load in, and there's hangers here. That's hung on the girder truss, and it's actually a double girder truss. So all of those loads come in singularly to that girder truss. The girder truss collects them and then brings that load to this joint here where we have a heavy-duty hanger, and then that puts the load into this beam, and half the load goes to that side, half the load goes to that side, and the result is we have this probably about a 15-foot opening by maybe about 3.5 feet for, this is where the stair is going to go up. So we had to make that stair hole. So that's what you're looking at there. And the reason you can tell it's a girder truss, you can see the bottom cord here has been doubled up. And so the plates are a little bigger, all of that. It just kind of scales up because the load is a little heavier than, say, just carrying the standard 40-pound live load of the living room floor above there. Again, not a whole lot of magic. One of the things about this house is that it's a pretty simple frame. It has two bearing lines. There's no intermediate bearing here, which basically gives us the freedom to manipulate the space down here and have it work very, very well for that ADU. You can see here we have our ductwork coming. We'll have some mechanical space over here also in the corner. Now, one of the beauties that I spoke of the truss was that, yes, we can run ductwork through there. One of the challenges of trusses are that, we could sit there and say in a drawing, okay, these trusses are 20 feet wide. But the reality is, the foundation guy puts his wall in, then we have to square up the mud sill, etc. Well, it might be that the width of the house is not 20 feet anymore, it's 20 feet and 3/8 or ½ inch, or maybe it's 19 feet and 3/4. And so we have to get the foundation up. My recommendation is always get the foundation up, then have the truss guy come out and measure basically the foundation to make sure that when they're manufacturing the trusses, they don't come out and they're a little bit short or a little bit long. They're exactly what we're asking for there. There are a couple places you can see here. We have a solid sawn rim board. Those are actually LVLs there. The reason we have the solid sawn band joist in this configuration is on all three of these walls, we have the deck outside as well as the entry deck, entry porch. So we wanted to make sure we had a solid band there that we can then structurally connect all of our deck framing to it, as opposed to down here where we will just run the sheathing down past the first floor bottom plate down to the mud sill below, and our sheathing will actually be our closure along this wall. Another small detail, as we look at the floor framing, this is a bathroom. We have a window up above. One of the things that I like to do is, instead of dropping this down, putting a header, and then having this window down here in the shower, having it up here allows me to get, a little bit more privacy, some place here for towel racks and stuff. Again, this is not a huge space. I mean, imagine living in a 900 square foot apartment for yourself. It's going to be great. It's going to be lovely, but it's not 3,000 square feet where we can give up space. So we're always thinking of ways to be efficient in the space. And so notice we put the header up here. The header bears on the foundation wall. Our mud sills just basically run across, and these handful of floor joists are basically hung from the header. So they're not in a bearing capacity here. They're basically hung by those joist hangers in that header, and that allows us to push that window right up against the mud sill on that side. So when it comes to, actual floor truss design, I've actually have done calculations in an academic environment going through school where we actually calculated all the forces coming into all of these different locations. But, these guys have sophisticated software that sizes all the plates and all of that. So I tell the basic truss company what I want, 14-inch floor trusses. And, we have a quick chat on the phone. Is it a 12-inch truss, a 14, 16, or is it an 18? In this case here, they are 14-inch. And then they develop the actual trusses. They send me the shop drawings. I review them, send them back to them with any notes or comments. And then basically when they get an approved set of shop drawings, then they basically manufacture. But they are also responsible for providing the information for the framer to install these correctly. So things like strong backs, which you can see here, these are nothing more than a 2x6 that runs through all of the trusses and gets tied to that vertical member in the truss. And that basically keeps those trusses from wanting to roll, right? It strengthens them to keep them in that vertical position and basically get them all to work as one. All right, so that's pretty much all of this floor frame explained. This one's installed. Why don't we jump upstairs? I think we got the framers there, and they're starting to set some of the second floor trusses there. We can hear them. They're getting after it. So why don't we head up there and we'll take a look. All right, before we jump upstairs, you get a really good picture here of the two moment frames here. Now, they're both moment frames. They're both resisting the lateral load that I spoke of earlier, but they're actually for two different reasons. We have this one down on the end here. You can see, when I talk about moment frame, what I'm asking you to focus on, you can see the gray steel beam and the gray steel column. The gray steel column comes all the way down to the foundation. It goes up to a beam. It goes over to a column that's behind the framing, and that column goes all the way down to the foundation too. It's a rigid structure. It's called a moment frame because it doesn't want to wobble or become a parallelogram, right? A moment frame is a very stiff frame that stays square in all four corners. Now, the reason we have one here is we have a door and a large window. Basically, there's no shear resistance in that wall system. So we needed a moment frame there if we wanted to keep that. The other option would have been to significantly diminish the window size there and not need to put the moment frame in and develop that shear resistance in the wood framed wall. We didn't want to do that for a number of aesthetic reasons, so we went with the moment frame there, and that helps aid the other moment frame, which we can see down here. You can see there's a gray beam that comes all the way across the second floor. It attaches to the column. That column goes all the way down to the foundation, but there's also that beam on the first floor frame, or this lower level frame that we talked about from the inside. This one is to totally resist the lateral load of that big open box. All right, so you can see that gray moment frame. We get a better picture about it, and we can talk about the floor framing when we get up there. So why don't we head on up there and we'll talk about it a little closer. All right, so, you know, one of the things about construction sites is it keeps me feeling young because I get to climb through here. Makes me feel like I'm climbing on the jungle gyms back in the younger days. So you see down below here, we have all of our floor joists. That is going to make up the second floor frame, which is going to be above us. We have yet one more story to go, and then we have the roof trusses that'll come on top of that. They're not on site yet, so everything you see down there is basically the floor frame above us. One thing I wanted to make note while we're topside here of the floor frame below, notice that for this project here, we've teamed up with Huber Engineered Woods, and we're using their Advantech X Factor, which is their premium subfloor. It's got an extremely high resistance to weather, water, very, very durable product. It's easy to do layout and markup on the top side here. It doesn't have that waxy surface, so it makes for a very, very good subfloor. You can see the guys here, we're starting to do the layout. We're putting up that first truss down at the end. We're doing some layout. We got some guys putting together the blocking. Remember, just like down below, we have that steel beam here that's going to get buried in a soffit. We basically have the kitchen here. The other side is the living room, and that's kind of a little dropped header that's going to help aesthetically divide these two spaces. They're building that top plate for it, so that's going to go up on top of the steel beam. It's going to get connected directly and bolted to that steel beam, and then the floor, when it gets set on top, we're actually going to have a floor joist that sits directly on top of that ties it into the floor diaphragm above, just like we talked about downstairs with the floor diaphragm of the floor I'm standing on. And like I said, over here you can see the guys are laying out the floor trusses. One of the things I wanted to call to your attention here that's a little different than, say, some of the other parts. Notice that that wall is in 1 foot from this wall, right? There's a 1 foot jog here, and that jog develops a cantilevered situation. So this double bottom core truss that goes out, it actually cantilevers over the header and it extends a foot beyond the wall there. And that's for aesthetic purpose on the outside. We have some different siding going on where this very large door is and such. But we'll have a cantilevered situation there, and then from the steel beam that way, we'll have our standard bearing point there, bearing point on the other side, very simple beam with, you know, standard installation. We got these trusses coming in. Why don't we let these guys have at it? Next time we return here, we can talk a little bit more about the floor framing. So until then, Steve Baczek, architect for The Build Show. So let's talk about the first floor plan. So I have it up here. Obviously we have that shed on that top side. We're just going to expand this a little so that we can bring it up in size. And let's slide this up. All right. So we have our front entry here. We have, you know, a generous front porch. It's not overly generous, but it's definitely proportional to the plan. You know, 8 foot by about 7 feet there. And then we have a deck here. The porch is covered, but the deck is open. And coming in, we have a generous mud room here where we have a bench and some closet space here, a set of double closets here. You know, one of the things about families and my own family, knowing that when you walk in the door, you're usually walking in with a bunch of bags or athletics, soccer bags. Like, you need that transitional space that you can go from the outside to the inside without having to carry this stuff through the house. So using this hallway as kind of the mud room in general here, I think works really good. Now remember, this house is only 2,000 square feet, so we don't have an allotment where we can give up 1,000 square feet to a mudroom here. So we want to be proportional to the whole when we're designing a house like this. Off of the mudroom, we have the powder room, right? And the beauty of that is if you're doing stuff outside, kids are playing, they can come in and you can kind of control like the dirt, the mud, the snow, anything from playtime activity, that you get access to the powder room without getting off of that tile floor. We then breach into this space, and then that takes us into the large living area. And the living area here basically is the 3 spaces. So we have our dining area down below. We have our kitchen in the midsection, so the kitchen has visual access to both the living area and the dining area. And then the living area is basically comprised of that space. Now, the thing that I really like about long, thin houses like this is the fact that this is southern orientation, this is northern orientation there. And so on the north side, I pack in all of the utility spaces, the stairs, the pantry, the powder room, and the mud room. And so that those don't really require a lot of sunlight. Those are more activity driven and spaces I'm going to go in, move out of really quick. The spaces that I'm going to come and relax are the spaces on the south side here. And if we go through these individually, we have a nice big window here to feed the dining room. The dining room also has a door that feeds out to the deck there with a nice glass window, full height window there that looks out onto the deck. On the kitchen, not only do we have the back cabinet here where we have our induction cooktop and our refrigerator, we then have a nice large island here, so that'll seat at least 4 with the sink, the dishwasher there. But we also have some additional cabinetry. Again, it's a 2,000 square foot home, so anytime we can squeeze in just a little bit more storage, it's advantageous to the client. And then, like I said, regardless of where you are, if I'm sitting here, I have that visual access to those 2 spaces, but then I have this large living space that's, on the order of 20 feet by about 17 feet there for 2,000 square foot house. Certainly more than adequate. The last thing I'll note is, I like to put furniture in the rooms. And the reason I put furniture in the rooms is that you can justify that the room is successful by putting that furniture in there. A lot of times I see floor plans, they don't have furniture in there, and the first thing that comes to mind is, where would I put the TV in that living room, right? So by actually drawing it and designing the parts that complement the whole, then the hope is that when we're done, we have a very successful floor plan. Hey, Steve Baczek, architect for the Build Show. We're out at our multi-gen project. Just want to take a second to thank one of our sponsors for being part of the project. Now, their sponsorship allows us to bring you all of this information. So credit to them for being on that educational train and allowing us to share some very valuable information with you. So Zip R Sheathing, it's by Huber Engineered Woods. Huber Engineered Woods creates systems for our exterior sheathing systems, our floor sheathing systems, and the Exacore product for acoustical and multifamily projects. Now, on this one here, we're using a Zip insulation product. It's their Zip R9. What that means is it has a resistance value of 9 built into the panel. I have a piece of it here. It is the standard 7/16 inch OSB panel, and then laminated to that is 1.5 inches of polyisocyanurate, so that we call that an R panel, basically outsolation. Now this provides continuous insulation on the outside of the house here, basically putting a sweater on the house and wrapping the whole house, very much like the jacket is doing for me in the colder weather. Now, it doesn't stop there. The beauty of Zip R Sheathing, in fact, is It is an exterior sheathing, closes off my building. It is an insulating sheathing, provides a thermal benefit and becomes part of my thermal barrier system control layer in the house. It is a weather resistive barrier. It has an integral WRB on the face of the sheathing. WRB, weather resistive barrier. It's dealing with rain. It also, even though it has insulating sheathing, it has shear numbers to it. So it can become part of the shear system for the overall house. There are numbers, our structural engineer uses them to calculate the shear. Lastly, it is our primary air barrier on our wall system. I said it's a system, it says system right on their board. And what that means is they don't just make the board, they make the tape to seal one board to the next board. And you can see that here, it's rolled. We have the flashing tape. In our window installation videos, you see we have stretch tape. We can make our pan flashings. They've totally developed the system where we can close in our buildings with that one system using one manufacturer's kit of parts to close it up. Thanks to Huber for joining in. Thanks to Huber for developing such a great system that makes our life real easy out here on the job site.